down by M. That will be an M by M matrix. Okay, let me pause for question. Any questions so far? Okay. So the next step I'm going to do is we're going to use very similar architecture for the synthesis. Okay, for the other side. So I'm going to draw down here synthesis. Okay, so you have H0, H1, downsample. In the reconstruction, what do you have? Upsample and filter. Okay, so in the bottom half, you will derive similar architecture. But now for the synthesis. Okay, so let's do it here. We have up by 2, F0, F1. Okay? All right. So here is question. So here is how we do this. F0 of Z, F1 of Z equals. Now, why do I have this as a row vector and this is a column vector? Because this operation here is serial parallel to serial, right? So if I imagine that this is U0, U1, okay? Then it's basically U0, U1, right? That product, F0, U0, F1, U1, would give me that output, Y. Okay? So instead of this is decomposition, right? From 1 to 2. I want to go from 2 to 1. The transpose form. Is that clear? Okay, so that's why we have a row vector instead of a column vector. So I want to derive the polyphase for the synthesis system now. Okay? So what do I have here? So let's call this Z inverse 1. We'll explain why Z inverse 1 and 1. Okay? It's clear that we want to have Z inverse and 1. We can change it to 1 Z inverse. But I'll show you why Z inverse 1. Okay? So if this is Z inverse 1, how do I write it here? This is now polyphase form. What will be the first? F0 of what? R. Very good. And why is F not even go to? Here or there? There. So instead of a row, right now you have a column. Okay? So you have F naught even. This square. And here is F1 or F1 even. Okay? Again, this is called Fp of Z squared. The definition for the polyphase for F. And again, for any choice of filter F, I can always find the corresponding polyphase representation and form this matrix. Right? It's a one-to-one mapping. The difference here is instead of a row corresponding to one particular filter, here's a column. Okay, any question on this? Equivalent representation using polyphase. So we want to copy this upsampling block here. Tell me what next. Is the matrix come first or the delay come? Matrix. How do I see that? Well, as before we said there's a vector here U0, U1, right? So I can imagine that there's a vector U0, U1 here. Okay? F0 times U0, F1 times U1. And that vector will not be appear here. It will be here, right? The same vector U0, U1 will be here. So that vector will see the matrix first, and then the delay. Okay? So we'll draw the matrix first, Fp of Z squared, and then the delay. Now, similar as in this case, where it is not efficient to implement a filter bank using filter and then downsample. Okay? We want to first block the input and then filter it at low rate. It is not efficient to increase the rate and filter. So we want to somehow move this block to this side. And we can do this by the second, right? From here to, I'm going to use a different column, okay? From here to here. This is second noble identity. So let's move this block this side. What do I say? Fp of Z. That is upsampling part, okay? So let's see Fp of Z. And then upsampling by 2. So let me put a box around the structure. This is a very important structure. This structure is equivalent to the cascade of these two, right? Cascade of this with that. That's your filter bank, right? You know, with the filter bank, we use 2 branches to decompose, and then we use 2 branches to reconstruct. So if you cascade this together into a system, this is the filter bank. And we just show that using polyphasic representation, and the first and the second noble identity, the equivalent form, basically a cascade of this and this. So are there any questions regarding what we have so far? No question. No question means I'm so good at lecturing. I'm not good at all. Okay, it's either very, very good or very, very bad. So which one is that? Very good. Okay. The matrix is the same as finding the filter. Right? If I know the matrix, I can find the filter and vice versa. So what is the condition on the matrix? Just starting at the ER. Is that condition easier to work with? Does it give you any new insight to the problem? So any idea?
SP multiplied by FP must be an.
So what he says is this product has to equal to 1. Why? Okay. Good. So those who know the answer, perhaps remember the lazy filter bank, right? That's the reason why I told you about this filter bank the day before this lecture. So you can actually use it to rewrite it, right? So what does the lazy filter bank look like? It is basically a way to block the input, okay, from serial to parallel, okay? So you have